Hello everyone, welcome back. In today's video, we are solving a strength of materials problem on bending stress in a hollow circular beam. We'll go step by step to calculate both the inner and outer diameters of the beam, given the bending moment and allowable stress. Let's get started. The question is, a hollow circular bar is used as a beam. Its outer diameter is 3 times the inner diameter. It carries a bending moment of 60 kN. Determine the inside and outside diameters of the beam if the permissible bending stress is 120 megapascals. The maximum bending stress in a beam is given by the flexure formula. This relates the bending moment, the distance to the outer surface, and the section's moment of inertia. For a hollow circular section, the moment of inertia is given by the difference between the outer and inner diameters raised to the 4th power, multiplied by pi over 64. And C is equal to d over 2. Since the outer diameter is 3 times the inner diameter, we can replace the outer diameter with 3 times the inner one. Substituting this relation makes the expression simpler. Now, substituting these values into the bending stress formula, we get stress equals 6 times the bending moment divided by 5 pi times the inner diameter cubed. Rearranging for the inner diameter gives diameter cubed equals 6 times the bending moment divided by 5 pi times the permissible stress. Substituting the values, we calculate the inner diameter to be about 0.0576 meters, which is 57.6 millimeters. Finally, since the outer diameter is 3 times the inner diameter, multiplying gives approximately 173 millimeters. So, the inside diameter of the beam is 57.6 millimeters, and the outside diameter is 173 millimeters. These dimensions ensure that the bending stress does not exceed the allowable limit. That's all for today's tutorial. If you found this explanation helpful, please like the video, subscribe for more strength of materials solutions, and share your thoughts in the comments. Thanks for watching, and see you next time.